Hello and welcome back. This is, I think, part 15 of the tutorial series on Hare, and this should be the final video for the tutorial. And this section is going to cover modules. So go ahead and navigate to this section. It's the last section of the tutorial, and let's go ahead and jump right in. So this is organizing your code in many files, and it shows a sample project layout. And it says, so far we've been putting all of our code into the same file, but as you step out into the world to write real Hare code, you would be well advised to organize your code somewhat more carefully. Each Hare module exists in a directory on your file system and contains some or all of the .ha files in that directory. Each file in this directory can use each other's private declarations, types, functions, and so on, and has its own separate namespace of imports, which are use statements. Thus, to expand your program into multiple files, you can simply write your code into several files in a directory and pass that path to Hare build or Hare run. You can also omit the path entirely, and these commands will assume you want to use the current working directory. And I'm going to get into all this. I'll give a couple more examples than just this right here. When you use a module, Hare will search for that module in your Hare path, which is a colon delimited list of directories to look through. The first directory is always the current directory, so if you want to add a private module called example, you can place its files at example and then whichever files.ha. The standard library is usually installed on Unix systems at user source Hare standard lib, and third-party modules are installed at user source Hare third party, both of which are configured in your Hare path by default. So this is an environment variable, right? Hare path, you can configure this. We recommend that you make liberal use of these resources in your work. Don't hesitate to read the source code for your dependencies. These are the basics, enough to get you started with real-world Hare programs. If you want to learn more about how to organize large projects, how to write Hare libraries, how to compile different code for each platform, and so on, check out the modules tutorial next. So what this is showing here, okay, it shows the breakdown of the project. And now if I run Hare version and pass in the V flag, it shows your Hare path. Now notice mine is user local, and if you installed Hare from source, yours will also be user local. Now if you're package manager, let me give a complimentary neofetch. I'm on Chimera Linux, which is musolibc. And if I say, and I'll search for Hare, and you see we do have Hare. So here's Hare, um, man pages. This is the Hare update tool, and then here's Hare C, the compiler. So if I were to install Hare this way, um, then this would be then this should be the standard path. So if you install Hare through your package manager, this is going to be should be the standard path. If you install it locally, then it's going to be user local. Okay. Um, okay. Let me clear this. And so in this example, we have our top level directory with our main file. Then we have another file named hello inside that same directory, our top level directory. Then this would be considered a module. And this is a subdirectory with a file called print inside of our main directory. So let's go ahead and create this. And what I'm going to do is, normally when I run a project, I have LF, and this is a file browser. There's nothing in here, so nothing is going to show up. But also, when I use Helix, there's a file browser, okay? Or you can open up buffers. Okay, but I'm not going to do that. I'm gonna just have three little separate screens here so that um, we can see the entire project structure at the same time. So let's go ahead and create main.ha. Let me copy this, and I'll make that right here. Okay, let me make sure. Let me um, make a modules directory. Okay, so here's our main file inside of our top level directory. Okay, um, clear this, and let's go ahead and just make these files. Okay, that way we can kind of visually see that this is our top level directory, right? We have a license and a readme. We have our main.ha file. Okay, now inside of our top level directory, we have a file called hello.ha, and we have this file. See, this shows the project directory, main hello. So let me put that here. Okay, so I'm inside of our top level directory. And I'll make hello.ha and paste this in. And you see it's just a declaration, right? Hello. And it's just a string. Hello world. Should be hello world. Okay, now here, let me. Okay, so now we're in our top level directory, and what we want to do, if you see, okay, from our top level directory, we need a directory called example, and then print goes inside that directory. Okay, so let me copy this, and we'll use this window. So make a directory called example. You see that here. Here's we're in our top level. Okay, so let me cd into example and make print.ha. Okay, so example print.ha. And I wanted to make it like this so that I can just go through each one, and we can just see, right? Because what I could do is, see, here's my file browser. Okay, so I could do that, or I could just open it in a different buffer, right, like this. But I'm trying not to confuse you, so I'm just trying to keep every file on a screen that we can see, so that we can sort of reason about what's happening a little bit better. Okay. Okay, so as you can see, we have imported the example. You see this is a use statement with example. Now that would be, if we go back here, that's this module. Okay, sorry about that. That's this module. So we want to import this module. Okay, and if we look, that's right here. Okay, so we're in print, the print.ha inside our example directory. And what we're doing is we're exporting this function. And in order to use a function from a module, you have to export it. Okay, and we're just passing in a string and printing it. Okay. Now, if we look at our hello file that's in our top level directory, you see we just have a declaration of hello. It's a string. So, and when you call a function that's in a module, you have to prefix it with the module name. So what this is going to do, it's going to print hello, that string. So we're calling this function, right? Export, we're exporting this from our example module. When you say export, you're exporting it from this module to use inside of another module, okay? If you did not want to include this export keyword here, you could still use this function inside the example module, but that's it, okay? And it can be inside another file, it can be in the same file, as long as it's within the example subdirectory. but we're exporting it, okay? We're exporting this function here, and we're calling it here, okay? Then we're passing in hello. Well, because hello is in our top level directory, it's visible it's visible to our main function by default because it's technically like in the same module. It's in the same. I don't think namespace would be the correct word, but I think so. It's in the same namespace, so we can call hello without having to export it. Okay, see, there's no export keyword here. It's in the same module. See, it's in the same top level module. Here's main, here's hello. So we don't have to export it, and we don't have to prefix it with a module name. Okay, so let me go ahead and save this, and let's save this, and let's go ahead and run this. And so you see it prints hello world. Now I'm just running the terminal from inside of Helix, okay? So that's just a terminal command. If I were to come out of here and say Hare run, you see it would be the same thing. Okay, so that's just it's a shell command. You can give like in NeoVim and in Helix you see run shell command. So that's all this is. It's a shortcut. Um, so that okay, so that's what's happening there. Okay, now let's say, for example, um, let me exit out of here, and I'll exit out of here as well, and back up into the top level module. Okay, now here we're in the top level module. Now let's make a directory called maths. Okay, we'll cd into maths, and let's I guess let's make a file called types. Okay, and what we want to do is have um, we'll make pi a floating point, say 3.14. Okay, so there's pi, okay, and this is a constant. Now notice it's not being exported, okay, so it's just a declaration that's that's inside of our maths directory, okay. Okay, it's in a file called types. Okay, now let's make a file called func.ha, and what we're going to do here is we're going to say export function, okay, and we'll print pi, okay, and we want to print pi. Okay, so now inside of our main um, file, our main translation unit, we'll say use maths, okay, because that's the name of our module. See, um, if I list the directories, you see here's maths. So we're in our top level directory, and a module is just a subdirectory inside of your main directory. So this is a module, this is a module. And so anything you want to use inside of one of these modules, you would import it as the name of the directory. You see use example, use maths, and generally what you would do is so you would say local, right, and then say you wanted to um, import things from the standard library, right, like the FMT module. That's generally how you would do it. You generally probably want to keep them separate. Oh, shoot. Excuse me. Okay, use FMT. So you generally want to keep them separate so that you can understand and so that someone else looking at your program can understand what's local, what's from the standard library, okay? Now, we have, okay, let's see where we are. Okay, let's cd back into maths, and inside of func, we have our export function. We're exporting this function to print pi. Okay, inside of our types, we have pi. Now again, this isn't being exported. Okay, so now let's look and see what happens. Okay, so now I'm I'm importing maths right here. Now let's look and see what happens if I say I want to print pi. So it's in maths pi. Okay, that's the type. That's technically the type. Okay, let's look and see what happens if I try and print this value. Okay, that's inside of types.ha inside of the maths module. Okay, it's not showing anything, but we should get. Oh, what did I do? Let's check this out. Okay, that should be. Okay, that should be right. Okay, now you see. Here, let me clear this and run this again. Now you see what's happening, right? Unknown object, and it's referring to pi. Oh, nope, FMT print line. Oh, I see what I did. Okay, I see what's going on here. So this is within the maths module, and what I want to do is I need to import the FMT module here because I'm using it here. Okay, so I apologize for that. Um, that's okay, mistakes are going to happen, and should always be welcome as long as you learn from them. Okay, so now let me run this. Okay, now this is the error that I'm looking for. You see unknown object maths pi, and that's because, as you can probably guess, inside of our maths module, inside of types.ha, we're not exporting this, okay? The only way that you can access this value, technically, is through this print function. And we're just printing it, okay? We're just printing it. That's all we can do with this value. So what we have to do is call maths, and I think it's called, and it's called print pi. Okay, so you would say maths, you prefix it, print pi, and then you call this function. I don't have to pass anything in. And what this is now going to do, you see I've removed maths pi because it's a value that we cannot access. Okay, it's private to that module. Now, when I run this, you can see it prints 3.14 because what I'm doing is I'm calling this function here and it's printing pi. Okay, well pi is in, again, pi is here in types. Okay, and here's func.ha. So here's pi in types. It's not being exported, but because it's in the same module, it's available to any file within that module. Okay, so whether I have func.ha or I have whatever else.ha, as long as it's inside the maths module, even though it's not exported, whatever it is, a function, if you want to embed that into a struct, anything anything like that, it's going, even though it's not being exported, it's available to any other file within that same module. Okay, but unless you export it like you're doing with that, like we're doing with the export keyword here with this print pi function, you export something when you want to be able to use it inside of another module. Okay, so let's say, for example, um, sorry, what am I looking at here? Um, Now let's say I export pi, okay? And, okay, so let me save this. Now, inside of our main file, now if I say maths pi, excuse me, now if I say maths pi, okay, oh, I see, I'm missing a semicolon, colon here. So now if I say maths pi, it's printing here because I now have access to it, okay, because it's being exported. Okay, so again, the export keyword is used to, if we look at the top level module, the export keyword is used to export something out of a module. Okay, so here's our module, here's our project structure. This is a module, it's a directory inside of our top level directory. And this is a module also. Okay, again, in hello, okay, notice that this is a declaration, but we're not exporting it, but you see it's inside the same directory as our main file, so I don't have to export this, okay? Hello is visible to this translation unit, okay? Anything in this translation unit, if it's not, even if it's not exported, is visible to anything in the same directory, okay? Now let's go into maths, okay? And so we have types. In fact, let me remove this. Let me remove the export keyword. So we have types, and we have func.ha. And again, these are in the maths module. Okay. Well, we're not exporting pi, but func has access to pi because it's in the same module. It's in the maths module. Now, so again, this is a way to provide like encapsulation, right? To provide like private types, private functions, and private variables inside of modules if you don't want um, if you don't want a user of your library to be able to manipulate that value from inside of their program, right? So when they import your module, when they import your library, you can have private declarations inside of your modules, and that's how, right, good software is written. So say you don't want a programmer to have access to Pi itself. Now they could get access, right? Um, but it's designed in a way that they're not supposed to be able to. Okay, they have to kind of go through extra steps to get to this value. Okay, um, but it can't be used outside of this module. That's the thing. Okay, unless it's exported. So the only thing that a person can do is call this function, which is print pi, and they can print it. Okay, well, if you have a struct and you're trying to do something with that, you do the same thing. You make it private to the module, and then you provide an interface, a public interface, right, through the export keyword inside of your module in order for them to access that and do whatever they need to do with it. Okay? Okay, so that is the modules section. And I think let's check out this modules tutorial here. Okay, using Hare modules. And you see, Hare modules are implicitly defined by the directory structure of your projects. Okay, for instance, importing foo bar, this becomes foo bar, which is appended to each element of the search path to find the source files. The search path always starts with the current working directory, then checks each of the default search paths in order. You can list the default search paths with Hare version v. So again, so here's your default search path. Here's your Hare path environment variable. You can customize this, okay? You can export this from your shell, right? Like from your bash RC. Um, and see, let's see what it says. So here's the standard Hare path. Now you notice mine is different again because I installed Hare from source. Okay, this this path right here assumes a package manager installation. You see, your local installation may differ, and you can override this. And you can override the search paths by exporting the Hare path environment variable set to a list of paths separated by colons. I'm going to assume you know how to export an environment variable from your shell, um, right? So it says, warning, if the Hare path environment variable is set, the default search paths are not used at all. If you want to add search paths, Rather than replacing the entire search path, make sure your Hare path includes the default path as well as your additions. So if you went to export, um, if I went and I wanted to export something from, I wanted to export it as an environment variable, you would have to first have the default search paths. Okay, so you'd want to put this in, and then this in, and then what you'd want to do is, add your custom search paths. Okay, after that. Okay, that's what that's saying. Okay, so um, that's what that's saying. And then it gets into some vendoring information, which this is like if you're packaging Hare for a distribution, um, stuff like that. You see, and it has an example program, and it shows a file structure, and so you can go over this more in detail if you want. This is under using Hare. Okay, so this is a great resource. Okay, I don't know why this is going so slow. I know what I did. Okay. Um, okay. Um, so this is a great resource, right? If you go to the documentation, say using Hare, it has project structure, and you can look at this too. Um, and it gives you an example of kind of the way that you should lay things out. Okay, for files, you can have copying, README, a make file, and it goes through this. And then what we can also do is say, and let's look at the very last part of this tutorial, and I'll go ahead and finish up here. Okay. Um, Okay, so you see, and that's the Hare programming language. Nice work getting through all of that. We didn't cover everything here. Check out the Hare specification if you want the comprehensive reference. If you encounter any unusual code out there in the wild that you don't understand, don't hesitate to reach out for help. Now, I will say this. On my channel, especially, there is no such thing as a ridiculous question. Okay? If you need help, then you need help. And I will always do my very best to answer any question that you have, regardless of how silly that might sound, your question, or how silly you might think it is. There is no such thing as a stupid question. Okay, there is no such thing. So please, um, if you have a question, please put it in the comments, and I will always try my best to help you. Um, Now, I'm not going to do this one, the standard library introduction, one because it's not finished. It only has like one part to it. But here's HA utils. And so if you click on this, right, you click on tree, here's the source code. Um, Let me make this a little bit bigger. Okay, and then this is the top level file, and you can see exactly how this is laid out. And what these are, you see these are implementations of POSIX system utilities written in Hare. Okay, and here's the make file, the readme, and this gives you a project structure, right? Right, how you would structure this basically. Okay, and one interesting thing about this project is if we look at the main function, okay, um, this function is shared. This is a main function that's shared between all of the different files. So that's really interesting. It's for all the different utilities, right? It's a shared main function. We might get into that later on. What was I just thinking about? Okay, this is what I was thinking about. If you go, okay, so this is the main page. If you click on Project Library, okay, here are a bunch of projects written in Hare, and you can browse these. Okay, and that might give you an idea of how these projects are laid out. With programming, With programming, there is usually more than one way to do things. But the thing I like about Hare is that there is generally only one way to do things. Sometimes by constraint, right? Like a feature in the language, it won't let you do something. And then you also have, like, well, what is the best way to actually do something? Okay. So you can sort of browse these projects, look at them, and get an idea of how they lay out their project structure. And how you lay out your project depends really on what you're trying to do, right? Um, your project structure might be different depending if you're making a game, a compiler, some piece of network software. It all depends on what you're trying to do. Okay, but they generally have sort of the same type of structure, right? So that's going to these are going to give you an idea of how to kind of organize your projects, right? So let me go back up to the top here. So let's check for any new releases or anything. Okay, there's nothing right now. Um, okay, so let me go ahead and wrap this video up by saying that is the end of the hair tutorial series, which took, I don't know, I guess the better part of almost a year. Okay, um, so I hope you found this helpful. Again, if you have any questions, please ask. I will always try my best to help you. Okay, so that is the series, the whole tutorial, the whole entire hair tutorial. And the next video that I put out will probably be us building a command line project so that you can kind of see a project structure. We'll have like a license and a README, and maybe I'll show you how to use SourceHut, and you can sort of, we'll actually make a real project from start to finish. That's a command line project that bootstraps your programs. Okay, how about that? And that way you're not having to manually create everything, um, from scratch every time you want to create a project. So that's it for now. I really appreciate you watching. I hope you found this helpful. I appreciate my subscribers that I have and any viewers to this channel. You're the reason I make this. I make these. I make these because I genuinely just want to try and be helpful to people. I remember when I first started learning programming, and again, I'm still learning. There's things that slip my mind or escape my mind. Sometimes, there's that old saying, sometimes we forget more than we learn, you know. Um, so I make these videos to be helpful because I'm genuinely, I like teaching, and I get satisfaction when people learn. Okay, when people get the skills to do things themselves, right? It's like that old sort of corny classic saying, right? You can teach someone to fish, and you can feed someone. I can't remember. You know what I'm trying to say. If you teach someone how to go about doing things on their own, now, the key to being a good programmer is not being able to keep everything in your head, okay? Because no one can do that. No one can keep everything in their head, and no one can learn everything, okay? The key to being a good programmer is knowing where to find information and how to decipher that information and apply that to what you're trying to do. I would say that's the key to being a good programmer, right? So, like when it comes to, you know, C, like here's the open system call. It's about knowing where to get information, how to decipher this information, right? How to put it in your program, how to actually apply this stuff, okay? Um, that's how you become a good programmer, is by understanding where to find the documentation and how to understand it. And of course, you do learn things, and there's a lot that you do keep in your head as time goes on. But that's the key to being a good programmer. It's not knowing everything, okay? It's not being able to do everything. It's knowing where to find the documentation, where to find the information that you're looking for, and then how to decipher that and how to apply that to whatever it is that you're doing. Okay, that's what makes a good programmer. Okay, so enough of kind of the rant there. That wraps it up for the entire hair tutorial series. Um, and I will get another video out soon where we make a project. Okay, and after that, I'm not sure what I'm going to do with this channel. It's going to be programming for sure. I'm not exactly sure where I'm going to go though. So that's it for now. Thank you so much for watching. I hope you really enjoyed this, and if you made it all the way to the end of this tutorial series, definitely give yourself a pat on the back because it took me almost a year to make all this. Of course, I've been limited by time, but I've tried to be comprehensive with everything that it's teaching in the tutorial. Of course, this is not everything in the language and everything that you can do. As you get more experience with the language, and you get experience reading the spec, you can understand what you can do with the language. And I would really recommend like a systems level C book, right? Like one that I am working through right now is by Love. That's the author's name. It's systems programming for Linux. Okay, so you can work through that because there's no replacement for learning C. Okay, and Hare, the documentation, um, the language itself is very C-like, and it sort of assumes a knowledge of C. Okay, so that's it for now. Um, Thank you so much to everybody, and so I don't keep this video going. Um, have a very nice rest of your day.